Hi and welcome back. So let's take a quick look at the fact that classes are callable. Now we've seen that before. We know that when we define a class, Python essentially makes it a callable, and when we call it, we get instances of that class. So let's take a look at that. Let's go ahead and write our program class again. So we'll do a data attribute here. Let's call it language, and we'll make that Python, and we're going to define our function attribute. So def say hello, and all I'm going to do here is the same as before. So I'm using the same example. We'll just say hello from, and then we'll interpolate program.language like so. Okay. So now what happens is that this class is callable. So we can call program, and when we do that, we now get an instance of this class. So it's a different object. It's not the same type. We can take a look at the type of P, and you can see here that Python tells us this type of P is program, which is of course in our main module. Now we can also look at the isInstance. So we can also use the isInstance function, and we can ask Python to tell us if P is an instance of program. And again, that's going to return true because it is indeed an instance of that particular class. Now, what's important to understand is that classes and instances of that class are not the same objects. And in fact, they have their own namespace. So if I look, for example, at the namespace in the dictionary of P, you'll see that it's empty currently. But if I look at the dictionary for the class, you can see that we have our attributes. We have our class attributes. So this is why we call these attributes class attributes. And so they belong to the namespace of the class. They're inside the class. They're class attributes. They're not inside the namespace of the instance. Now, just as with classes, instances may have attributes that are not visible in the dictionary, in the dict. So we'll come back to this later, but just be aware that not everything, not every property that an object has is necessarily present in that dictionary. It can come from other places as well, especially also once we start looking at inheritance. For example, we know that Python provides an attribute on objects called dunder class, which will tell us the class. So if we look at that, we can see that this object P, which has an instance dictionary that is empty, it still has this property. As you can see, we have P dunder class that returns whatever the class was that P was created from. So another way, of course, of doing it, and I want to point this out, is that we can do the type of P, okay, and that's really going to be the same thing as P dunder class, like so. So you might be wondering, well, should I just, instead of using type, can I just use dunder class all the time? No, you can, but it's not entirely safe because it is possible for developers of classes to mess around with this dunder class property. It is, after all, just a property, right, on the object. So if I do this, let's go ahead and let me show you an example. So I'm going to create this empty class. It's not going to do anything. And I'm going to create an instance of my class. And now I'm going to look at the type of M, and I'm going to look at M's dunder class attribute, and as you can see, it gets the same thing. So in this case, works just fine. But now let me go ahead and define this. Let me say class my class, and I'm going to redefine what the class attribute is in here. I'm going to say, hey, this is a string. Okay, so now if I create an instance of my class and I look at the class property, the dunder class property of M, and then I'll look at the type of M as well. You'll see that what comes back from the dunder class attribute is a string. But type, on the other hand, is more intelligent than that. It figures out that the instance M was created from my class. It's not a string. So it is safer to use type. Now, isInstance is actually a little different. Let's take a look. We can check that isInstance of M, and let's say that we want to see, is it an instance of my class? We get true, and that is indeed true. Now, what we did by messing around with the dunder class attribute is change things a little bit, and this relates now more to metaprogramming, but let's take a look at isInstance_m of string. That returns true as well. Now, if we try and do isInstance_m, let's say, of an integer, we get that that's false, obviously, right? But because we messed around with this class, isInstance now also recognizes my class as a string. So it's not important right now, but I just wanted to point that out. And just to make sure, just want to show you that if we don't mess around with that dunder class attribute, if I do now an instance of my class, and if I do isInstance_m, string, you'll see that that is now false. Okay, so indeed it was messing around with this attribute in the class that affected this. All right, so as you can see, type wasn't fooled, right? It knows that this was created from my class, and isInstance is actually able to work with both. So we'll keep that in mind as we progress through this course. But in general, don't use dunder class, because that gets to be problematic unless you know exactly what you're doing and that's really what you want. In general, in Python, when we want to check if something is of a certain type, then we'll use isInstance. That's usually the more common one, and you'll see why when we get to inheritance. Otherwise, we can also just use the type function and just get the type directly that way. All right, thanks for watching, and I'll see you in the next video.